Yes. Okay. Huh? Yes, sir, ma'am. Sir. Okay. Hello, hello students. So yesterday we have discussed the isomerism and like introduction and isomerism and method of preparation of alkynes. Now it's time to recall the concept. So we have studied that isomerism. So we four types of isomerism this alkynes can show. First is chain isomerism, in which we have seen that 5 carbon chain can be converted into like four principal carbon chain, and then position isomerism, in which we can change the position of this double bond, like here this is 1 butane and here this is your 2 butane. Okay, in functional group isomerism we have seen that here alkyne can be show functional group isomerism to alkene. Okay, this kind of skeleton we have seen, or like this double bond can be here. And then ring chain isomerism, we have seen that like this C triple bond C, and we can also make a ring from this compound. So this was your chain isomerism. Next was method of preparation of alkyne. So we have done dehydrohalogenation. What we have done in presence of base. So base की presence में आपका डिहाइड्रोहेलोजिनेशन हुआ था, देन यहाँ से आपका HX रिमूव हुआ था, then HX plus we already had base, so it can form your KX means salt plus water. So this reaction plus your alkyne. Okay, so this reaction can be ended up like this. Then by dehalogenation of tetrahalide, so if you have tetrahalides like this kind of skeleton is there, then you can take zinc and remove this 2 halogen and form your alkynes. Okay, then dehalogenation of halo form. So we have taken like CHI3 plus silver plus I3 and CH. Then we have removed from 6 Ag here 6 AgI and alkyne form. Okay, and then synthesis of carbon and hydrogen. So we have given electric arc to them and they will form a acetylene gas. So this was the yesterday concept we have studied, like not yesterday, yesterday, not yesterday, previous day, I think Wednesday. Now this is a question for you guys. So I want to know that whether you are able to answer it or not. So I have put timer here. So kindly answer in the chat box so that I can know whether you have understood or not. So this is your reaction for dehydrohalogenation. Dehydrohalogenation in the presence of base. So we have removed this halogen and hydrogen from here and formed one X should be there and formed halides. So we have prepared alkynes from here. Okay. So this was yesterday like previous class concept. Now let's move on to the today's class. So now today what we have to learn, we have to learn the physical properties of alkyne. Okay, so we have discussed that some introduction, and then we have discussed introduction. Okay, then nomenclature, then isomerism, then method of preparation. Now it's time to start physical properties of alkyne. So like all other compounds, alkane and alkene, we have discussed that lower molecular mass compounds are gases. If we take 8 carbon, then it will be liquid. If more than 8 carbon, then it will be your solid. Okay, as the molar mass increases, your solid, your compound becomes solid. Okay, then alkynes are somewhat polar in nature. Why polar? See here, this hydrogen is attached with sp carbon, so sp carbon is more electronegative. That's why these alkenes become polar in nature, and their boiling and melting point also increases as their molar mass increases. So these were some common physical properties of alkyne. So I think this is clear. This was like a repetition of previous compound in which we have studied that they are, if they are lower molecular mass, then they will gases. Molecular mass increases, then they will convert into liquid, and higher molar mass will be solid. And this is new. Okay, polar in nature. I do other hydrocarbons not that much polar, but this is polar in nature. So now and as the boiling and melting point, so as the molecular weight increases, the boiling and melting point also increases. Okay, so I think इसमें कोई डाउट नहीं है, अगर है तो चैट बॉक्स में आप लिख सकते हैं. I'm waiting for the chat box. So no doubt, I guess. So now move on to the next topic, which is your chemical properties of alkyne. No, 1 minute, it's taking time. I don't know why. So next is your chemical properties of alkyne. So first of all, acidic nature. So this is quite important and different from your alkane and alkene. Why? Because like, see, I have already discussed that this carbon is sp hybridized. Okay, sp hybridized means percentage as character is 50%, and you know that percentage as character is directly proportional to the electronegativity of atom. So as the percentage S character increases, the electronegativity of atom is also increases. Okay, and if electronegativity increases, then this carbon and hydrogen bond become polar, and this negative charge become more stable on carbon. So if we remove H plus from here and give negative charge to this sp carbon, then it is quite stable. So that's why this hydrogen is released from here, and we say that our alkynes are acidic in nature, slightly acidic in nature. Okay, so how we have proved it? We have proved it by uh, taking the reaction with Na. So what Na did, and Na removed from H2 gas from here and formed salt with alkyne. Okay, so you have to remember that alkynes are slightly acidic in nature. Okay, Next we have some reaction, we have some addition reaction for alkynes, so in which addition of dihydrogen, addition of halogen, and then addition of water. So look, dihydrogen addition we have discussed several times, not in the preparation of alkene. You have seen the preparation of alkene, like we can add hydrogen to this unsaturated system, like this kind of system, and we can get alkane. Okay, so if instead of double bond here triple bond is present, we can also add hydrogen and form a saturated compound like this. Okay, but problem is this, we cannot do hydrogenation like directly like this. We have to take a catalyst. Which catalyst? हाँ, चैट बॉक्स में लिखो अगर आपको पता है तो कौन सा कैटलिस्ट है। यहाँ पे एक कैटलिस्ट हम यूज करते हैं ना, वो कैटलिस्ट बहुत इंपॉर्टेंट होता है। अगर आप वो कैटलिस्ट नहीं लोगे तो ये रिएक्शन नहीं होगी। ओके, सो कैटलिस्ट विल बी योर निकल, पीटी और पीडी। ओके, वी हैव टू टेक द सेम कैटलिस्ट हेयर ऑल्सो। ठीक है, नाउ एडिशन ऑफ हेलोजन। सो हेलोजन एडिशन भी हमको सेम एज we have done in the chapter alkenes, like double bond, then we have to take X2 with a non-polar solvent. Non-polar solvent क्या था हमारा? CCl4 kind of, and then we have broke this bond and added halogen at vicinal position. Okay, the same concept will followed here, and we will take halogen and then break one bond and add halogen here and break this like this kind of reaction. This will be your intermediate product. Then we can take more X2 and form a tetrahalide. Okay, this kind of reaction can be done. And addition of water, same addition of water, follow the rule as we have discussed in alkenes. Okay, like if acidic condition is present, then it will follow your Markovnikov rule, and then if your peroxide is present, then it will follow the anti-Markovnikov rule. Okay, so next we will discuss this reaction in details. I have just briefly introduced you with the reactions. Now addition of dihydrogen. Dihydrogen means H2. Okay, so if C3H4 is present, C3H4 means like CH3, your C triple bond CH, this is your C3H4 is present. If you take 2 mole of H2 gas, then it will add to this double bond. This will break this two double bond and add, and we will get C3H8, which is what? Which is our propene, sorry, which is our propine. We have studied in the chapter alkanes, so we will get propane. So we can get a saturated compound from an unsaturated compound by addition of H2 gas in presence of Ni, Pt or Pd. Okay. Now addition of halogens. Same process will follow here. Addition of halogen, what it will be? It will be halogens means your X2. So if you are taking alkyne like CH triple bond CH, so you have to break these two bonds to get a saturated alkyl halide. So first you will you will take 1 mole of X2 and one bond will be break, and CHX and CHX will form here, and then your double bond remain intact. Then if you take another mole of X2, then this bond also break, and you will get your tetrahalide. Okay, what you will get? You will get a tetrahalide in this reaction. Okay. So this is quite simple reaction because nothing new here. You have already discussed these things in alkenes chapter. This is a revision kind of class, I can say. Okay. Now look, addition of water. Addition of water you have studied in alkene, that this addition of water can be done via two different process. Like if you take H plus as an acidic condition, or oxymercuration, demercuration, oxymercuration and demercuration, oxymercuration and demercuration, where what you have take mercuric acetate, OAC cut twice, plus NH4 NaBH4, 1 minute, sodium borohydride, NaBH4, sodium borohydride. So this will follow your Markovnikov rule. Okay, and if you take B2H6 with B2H6 along with H2O2 or peroxide, then it will follow your anti-Markovnikov rule. Okay, so anti-Markovnikov rule. Okay, here it will follow your Markovnikov rule. Okay. Now we have taken ethyne here. Ethyne means CH, triple bond CH. If you add H2O, so here you know that why acidic condition is required. Acidic condition is required because look, this is a electron dense system and your water is also nucleophilic. So if both the substance are nucleophilic, this reaction cannot take place. If you want to proceed this reaction, you have to take first a electrophile, so that one nucleophile can react with this nucleophilic system. So here we have taken it as a H plus. Okay, so in the presence of H plus, this system will this density will shift it toward the one carbon. Like if we can say that if this here this is symmetrical alkene is present, so no need to worry about the shifting of electron. Carbocation may be formed and any of the carbon same yoga. So this density will shift towards this carbon, and this negative charge form a hydrogen bond with this form a bond with this hydrogen. Okay, so we will get CH2 and this double bond remain intact. So this double bond is as it was. Then this CHOH, then kind of intermediate will form this CH2 CH2 CH positive. Okay, CH2 double bond CH positive. Now this water will attack on this system. Okay, and you will get CH2 double bond CHOH2 positive. Okay, now H plus is removed and you will get your ethanol or enol kind of system. Look, now I need to explain here something, which is this. Like if your CH2 double bond C H OH is present. So this is your E, like what is it? E, na, alkene. So this is your E and this is your ol. Okay. So this is a enol kind of system. It can be tautomerized. I think you have studied tautomerization in isomerism chapter, but if you not, I can explain here. Like this lone pair of nitrogen will move like this, and this double bond will be shifted to the carbon atom, and here negative charge will be on carbon, and then your C double bond OH positive. So here intramolecular proton transfer reaction, intramolecular proton transfer reaction, and this hydrogen will attach to this negative charge. So we will get CS3C H double bond O. So one thing you need to remember here, that in the hydration of alkenes you get alcohol. Okay, simple, you get alcohol 1 degree or 2 degree depending upon the stability of carbocation or Markovnikov rule. But here you need to remember this reaction will not stop here, because keto form is way more stable than as compared to enol form. So this reaction will proceed further and you will get your keto form. Okay, so you will end up with ethanol, which means your keto form. Okay, Similarly, here this mechanism is same, but I need to stretch this point. Here, look, now we have choice that we can form carbocation here or here. So you know that this first carbon is your attached with a alkyl group which will stabilize this carbocation. So we will form a carbocation on the second carbon and attach OH to the second carbon. So we will get a ketone. Okay, here we what we get here we get aldehyde. Okay, here we will get a ketone, propanone. Okay, so I think addition of water is clear because this is something different from alkene, which you need to remember. Okay. Similarly, अगर यहाँ से आप this B2H6 and H2O2 will taken, then this reaction will also go via same mechanism that you have studied in alkene, but after the formation of enol, you need to convert it into ketone. Okay, the final product will be ketone in the reaction. Okay, now here a reaction which is ozonolysis. Ozonolysis, you have ozonolysis also you have done in the your alkene chapter, where what we do, we just simply break this bond and convert it into CO and OC like this. If this is your it was your ethene, then you will ended up with 2 molecules of formaldehyde, HCHO, है ना? यही होता है. Now listen. The important thing is this here, this reaction will not go like this in the alkynes. Here you can see this reaction will, like, you get 2 molecules of aldehyde or ketone depending upon the substituent what is added here. Okay, so you will end it up with aldehyde, but in the alkyne this reaction is not like this. In this reaction you will form a ozonide. Like, first of all, this carbon-carbon triple bond will react with O3, and form a ozonide. Like, this bond will break, these 2 bonds will break. Okay, and the ozonide type of skeleton will be formed. This, okay, like this and this. Look here, if you want to form a ozonide, this 2 bonds should be broken between the carbon. So there is no bond between a carbon. So they both the carbon get separated during the ozonolysis. But here we have 3 bonds, so 1 bond will remain intact in the in the formation of ozonide. Then what will we do? We will take a reducing agent like zinc or water, then it will remove your oxygen, this oxygen from here. So how this ozonide will break? This will bring like this, and this is this, or this oxygen can be removed by a zinc, and ZNO will form. So what you will get? You will get like this C, single bond C, O, and here this is also, this bond is broken, but here double bond form. So here oxygen will attach with double bond, and this bond is broken. So this is this kind of glyoxal you will get. Whatever it will called, glyoxal. Okay, it will call glyoxal. So this glyoxal, if you on hydrolysis, this glyoxal can also be converted into your acid. Okay, first aldehyde, then acid. So this is quite important reaction, ozonolysis. You need to understand this reaction as compared to alkene. In alkene we just broke 2 bond and form attached oxygen and oxygen on the both side. But here this you need to learn that this carbon-carbon bond, this carbon-carbon bond will remain intact in the reaction. So we will ended up with the glyoxal. Okay, so this is what we have learned so far. Okay, next step, polymerization. Okay, So our acetylene can be polymerized with the red hot iron. Okay, high temperature is needed. Look, 873. So our room temperature is, what is our room temperature? 298, and we have to take it from 873. Are you getting how much temperature we need to form benzene? Okay, so benzene is very stable compound, very stable. So formation of benzene cannot be as simple as we think. Okay, so we have to take these three acetylene molecules, and this we can break this triple from one to every acetylene moiety. So what you will get? You will get a free valency here, then CH free valency here. Okay, then CH free valency here. This free valencies can be added like this. Okay, so you will get your benzene. तो अगर आप बेंजीन की प्रॉपर्टीज जान लोगे ना तो बेंजीन आपका फेवरेट मॉलिक्यूल हो जाएगा. इतना अच्छा है बेंजीन, सो स्टेबल. नेक्स्ट है so I need to first summarize like, or I will summarize you in the last slide. Okay, so 1 minute. So what we have studied like method of preparation of chemical properties of alkynes. So in the chemical properties of alkyne, first we have studied that hydrogenation. So hydrogenation was also the proper method of preparation of alkane. Chemical properties of alkyne can also be method of preparation of alkane. समझ रहे हो ना? तो आपको ज्यादा रिएक्शन याद करने की जरूरत नहीं है, आप एक दो याद करो, काम हो जाएगा आपका. एक ही रिएक्शन याद करो, दो जगह हो जाएगा. मतलब इस तरीके से आप इसका हाइड्रोजनेशन कर सकते हो NiPt and Pd के प्रेजेंस में, and you will ended up with alkane. Okay, you will ended up with alkane. Okay, next, halogenation. Halogenation we have studied. So in the halogenation, you will take alkyne, then first mole of X2, you will get alkene halide, then another mole of X2, you will get tetrahalide of alkenes. Okay. Third was addition reaction. So this is all your addition reaction. Okay. Third was addition of water. Third was addition of water. Water का addition हमने देखा था. So we need to ended up with aldehyde or ketone. Okay, we need to ended up with aldehyde or ketone because enol form बन जाएगा. Then enol को we have to convert it into ketone. Okay. Then polymerization we have discussed. Polymerization में अगर आप 3 molecule of CH like C2H2 लेंगे, then you will get benzene. Okay, very stable molecule. Okay, now it's time to study the uses of alkynes. So सबसे इम्पोर्टेंट एंड फर्स्ट यूज है, मोस्टली यही पूछा जाता है, ऑक्सी एसिटिलीन गैस वेल्डिंग में यूज होती है. ओके, कटिंग ये सबसे इम्पोर्टेंट है. अगर इससे यूजेस से क्वेश्चन आया तो यहीं से आएगा और नहीं तो और कहीं से नहीं आएगा. ओके, then we can also use fuel as a fuel. We know that we use hydrocarbon as a fuel because hydrocarbon on combustion give a lot of amount of energy. That's why we have used them as a fuel. Okay, then mostly in the preparation of crude material. Okay, just let's say ethanol, इन सब के लिए crude material को भी हम as a crude material भी हम alkynes को use कर सकते हैं. Okay, so this was all about the today's class, and we have ended up with our alkynes. Now it's time to do some practice questions to know that whether you have understood the concept or not. Okay, so question for you. I'm taking 30 and I'm giving 30 seconds to you. Now you need to answer the question. Okay. What it will form. So here what they have taken, that they have taken your CH3, CH2, CH and Cl and Cl. Now I have make your task easier. अभी तो कुछ भी नहीं है. Now they take what is their taken, NaNH2. So NaNH2, what NaNH2 do? NaNH2 NaNH2 will act as a base here, and it will remove hydrogen, left negative charge, then it will move and your halide will remove. So you will ended up the reaction called dehydrohalonation. Okay, मतलब कि D मतलब removal, hydro मतलब hydrogen, halo मतलब halogen, and you will ended up with the alkynes. Okay, so your right answer is alkyne. Okay. Now next question. Polymerization product of propyne is. So we have seen the polymerization of ethylene. Okay, एसिटाइलिन गैस का पॉलीमराइजेशन हमने किया है C2H2 का. अभी आपको प्रोपाइन का पॉलीमराइजेशन करना है. Propyne means 3 carbon chain, and ine means there is double bond between 2 carbon, and we have to fill the valencies. So this will your propyne. You need to polymerize this propyne. Okay, so what you will get, I am giving some time to you guys. Answer it in the chat box. So your propyne will polymerize here like this. We have already we have already explained in the previous slides. Now look at the answer. You will ended up with macetylene. This. How it will form? It will form like this. You will get C triple bond CH, and your CH3 will here. Okay, then CH, and your CH3 will here, and CH, and this kind of your CH3 will here. So we can polymerize. We can break this bond, and this bond, and we will ended up with this product. Okay, so what is it called? It's called macetylene. Okay, if alternate 3 CH3 on benzene is present, it will call macetylene. Okay. So homework for you guys is here. Homework for you. You have to write the IUPAC name for this compound. Okay, I will ask in the next class. Next question is, 1-butene and 2-butene can be identified by using which of the following reagent? This is an interesting question. We have discussed this concept, but you have to think a little bit. Okay. So I'm chat box में answer. Look, 1-butene, make the structure of 1-butene and 2-butene and try to try to solve the question. Okay, let me do it. 1 butane means you have to take 4 carbon first, and your ion will be your at first position, and you will get like hydrogen here. Okay. Now 2 butane means this double bond between the at this position, and you make the fill the valencies CH2, and like this CS3 CH3. Okay, so here you can see this can be identified by using NaNH2. Why? This is your base. Okay, and we know that this hydrogen is acidic in nature, but here no hydrogen is attached to the carbon sp carbon. So base can identify base can differentiate in between these two alkynes. Okay, so this was a quite interesting question. You have to think little bit. Answer is C. Okay. Next, which of the following is used for welding? तो welding में कौन सा use होता है? अभी बताया. यही से question आएगा. अगर आएगा तो इसका आंसर क्या है? C2H2. Okay. Next is in the ozonolysis reaction, acetylene forms. एसिटिलीन गैस ओजोनोलाइसिस रिएक्शन में क्या बनाती है? अभी हमने देखा उसी पे बेस्ड क्वेश्चन है आपका. ओजोनोलाइसिस में अगर आप O3 के साथ करेंगे देन सबसे पहले ओजोनाइड बनेगा. सबसे पहले ओजोनाइड बनेगा. ओके, this will then we have to take a reducing agent, and this carbon carbon bond is intact. This carbon carbon bond is intact. Then we will get CO. Then we can convert it into by hydrolyzing. We can convert it into acid. Okay, COOH plus COOH. Okay, so this is your glyoxal. So glyoxal, and this is your formic acid. So we can form here carbon. इधर hydrogen था. Hydrogen. So HCOH is your formic acid. So you will get glyoxal and formic acid here. Okay. So next question is the product formed in the reaction of ethyne with dilute H2SO4 and Hg2 plus. So Hg2 plus and dilute H2SO4 है और आपकी ethyne है. Ethyne means same CH triple bond CH. Now you have to do the reaction. What you will get? We have also discussed this reaction. So in the acidic condition, your water will add here, and you will get like CH double bond CHOH 1 2 CH2. This enol system you will get, and then you have to do tautomerization to get CH3 C double bond O. हाँ, तो क्या मिलेगा? Ethanol. Okay, you will get ethanol. Al means aldehyde group, na? You will get ethanol. So answer is C. Okay. So if we look the summary, so I have already summarized the class. What we have studied chemical properties of alkyne. So first is your acidic nature. Why it is acidic? Because carbon is sp hybridized. So sp hybridized carbon is there. So base can remove your H plus from here, and then your alkynes are become slightly acidic in nature. Then we have discussed your addition reaction. Okay, इसमें हमने अभी देखा हाइड्रोजनेशन क्या, हेलोजनेशन क्या, एडिशन ऑफ वाटर क्या. वाटर में आपको कीटोन पे जाके रिएक्शन को खत्म करना है. देन पॉलीमराइजेशन. सो पॉलीमराइज्ड प्रोडक्ट वी हैव डिस्कस्ड benzene. In benzene we will get from ethylene gas, and acetylene we can get from propane. Okay, so addition reaction we have discussed. Then some question we have done, and like physical properties. So physical properties में what we have done in the physical properties. Physical properties में if your molecule is lighter, then it will be gas. If it will be little heavy, then it will your liquid. If more heavy, more molar mass, then it will become your solid. Okay, and your melting point and boiling point is directly proportional to the molar mass. As the molar mass increases, the melting and boiling point increases. Why? Because your van der Waals force of attraction increases. Okay, so this is your summary for physical properties. नेक्स्ट यूजेस. तो यूजेस आपको एक मोस्ट कॉमन यूज तो आपको एक पता है सबसे पहले कि एज अ फ्यूल यूज कर सकते हैं. दूसरा है आपको ये ध्यान रखना है कि इस जो एसिटिलीन है C2H2, इसका ऑक्सी फॉर्म जो है वो बेल्डिंग के लिए यूज करते हैं. ठीक है, इसलिए यूज करते हैं बेल्डिंग. So we have done with alkynes. Now next onward we will study next topic. So I am stopping it here. If anyone has any doubt, please write in the chat box so that I can make it clear. I think no one has any doubt, so I'm stopping it here and I'm ending this meeting. Okay. Hello.